The M-Drive, an experimental propulsion device, may be producing a warp field. According to posts on the NASA Spaceflight Forum, it was found that some of the beams were traveling faster than the speed of light.
For decades, the speed of light has been the universe's ultimate speed limit, the wall that no technology could ever break. But NASA may have just found a crack in that wall, and what's behind it could redefine the future of space travel forever. The discovery isn't a rumor, it's real research, backed by equations, experiments, and theories that hint at something far beyond rockets and engines. Join me as we uncover what NASA just admitted and why the world isn't ready for what comes next. The spark of the rumor, the idea that NASA might have created a Lightspeed engine, sounds like science fiction, and in many ways it is, but there's more truth to it than you might expect. Over the past few years, NASA has openly discussed research into warp drive-like concepts that could, theoretically, allow faster-than-light FTL travel. In particular, the concept of a warp bubble emerges. Instead of pushing a ship through space, you warp space itself, allowing the ship to ride inside a moving region of space-time. That's where the rumors began to swirl. Because if you can warp space itself, then from an outside observer, it might look like you're going faster than light, even though locally you're not violating the laws of physics. It's subtle, and that's what makes the claim so tantalizing and so scary. But let's be clear, NASA has not announced we can now travel at light speed tomorrow, and the science remains speculative. The rumor is grounded in real research, but far from deployment. The science behind the claim. To understand what's truly possible, we first need to look at how light speed travel fits into real physics. Albert Einstein's theory of special relativity tells us that anything with mass can't reach the speed of light in normal space because it would require infinite energy to do so. That's the unbreakable rule of the universe as we currently understand it. But there's a clever loophole, one that doesn't move the ship through space, but moves space itself around the ship. This is where the warp drive idea comes in. The most famous version is the Alcubierre drive, proposed in 1994 by Mexican physicist Miguel Alcubierre. Instead of pushing a spacecraft forward, it bends space-time, compressing it in front of the ship and expanding it behind. The craft itself doesn't move faster than light locally, but the bubble it sits in carries it along at effective light speed or even beyond, relative to the outside universe. NASA scientists, including Harold Sonny White, have been quietly exploring whether something like this could be more than science fiction. In controlled experiments, they've studied miniature warp bubble effects, not to send ships across galaxies, but to understand the physics behind these strange distortions. Their goal is to find ways to lower the unimaginable energy cost such travel would require. It's a field that blends serious science with daring imagination. Nothing close to a full-scale warp engine exists, but the mathematical groundwork has given rise to intense debate. Each new experiment, each subtle shift in understanding, feeds the rumor mill. And that's where the viral claims about NASA creating something that can reach light speed start to emerge. While the literal claim is exaggerated, what's fascinating is how close research is edging toward concepts once dismissed as pure fantasy. The line between fiction and future technology is getting blurrier, and NASA's latest findings are a perfect example of that gray zone. Why it's terrifying. Why would such technology, if ever proven real, inspire fear rather than pure excitement? The first reason lies in what it means for time and reality itself. The instant something moves faster than light, the normal sequence of cause and effect starts to blur. According to Einstein's equations, time slows down dramatically at high speeds and can even behave unpredictably when light speed barriers are crossed. The idea of stepping into a ship and returning to find that decades or centuries have passed outside is deeply unsettling. It suggests that light-speed travel doesn't just move you through space, it could separate you from time as you know it. The second source of fear comes from the strange physics involved. To achieve faster-than-light motion, theoretical models rely on forms of energy that don't exist in any stable way. Negative energy, exotic matter, and distortions in space-time that we can't yet control. These ideas come from advanced mathematics, but nobody knows what would happen if they were ever applied on a large scale. The energy requirements alone could dwarf anything humanity has ever handled, and even small experiments could create unpredictable effects. There's also the question of safety for the surrounding environment. Warping space doesn't just move a craft, it bends the very structure of the universe. That could unleash intense gravitational forces or high-energy radiation. If a warp bubble formed or collapsed near Earth or another planet, it could cause serious disruption to nearby systems. Even theoretical papers have warned of potential hazards like space-time instability and radiation bursts. Beyond physics, there's a social and ethical dimension to fear. The thought that one nation, agency, or private group might control a lightspeed or warp technology introduces unease. Whoever masters such power would instantly reshape global dynamics. The potential for misuse, secrecy, or accidents would be immense. A single mistake could have cosmic consequences, and even controlled experiments could carry unknown risks. So even if the viral rumors stretch the truth, the emotions behind them make sense. Just knowing that real scientists are probing these possibilities is enough to stir both excitement and anxiety. The deeper humanity reaches into the universe's hidden mechanics, the more we realize how fragile our understanding still is, and that realization alone is what makes the idea so terrifying. What NASA has acknowledged. Let's take a closer look at what NASA has actually confirmed. On their official website, NASA published a document titled 3 Ways to Travel at Nearly the Speed of Light. It lays out how scientists are exploring realistic methods of high-speed travel, such as accelerating particles to near-light velocities, and what future propulsion systems might look like if we could ever approach such speeds. The document discusses technologies like photon sails, antimatter engines, and advanced plasma propulsion, all of which exist more in theory and laboratory studies than in any real spacecraft today. NASA has also conducted work under initiatives such as the Breakthrough Propulsion Physics Program, which was set up to test the boundaries of what might one day be possible. This project aimed to explore new ideas in physics that could dramatically increase spacecraft speed, but it also emphasized the huge scientific and engineering barriers that remain. These include energy demands far beyond what humanity can currently produce, and the problem of controlling space-time itself in a stable, predictable way. In various press releases and conference summaries, NASA has been transparent about the limits of this research. They have repeatedly explained that the concept of a warp drive, or faster-than-light propulsion, is still purely theoretical. The math may work on paper, but there are no physical systems capable of producing or containing the amount of energy required. The scale of these challenges means that such travel remains far out of reach, at least for now. This honesty, however, hasn't stopped speculation. The public often interprets NASA's experiments as secret progress toward light-speed travel, when in fact, these projects are about exploring the underlying physics, not building an operational engine. Still, the fact that NASA scientists are even studying these ideas is enough to spark excitement and, inevitably, rumors. That gap between theoretical research and actual engineering creates a perfect space for wild claims to spread. NASA may not have said they've achieved light speed capability, but their willingness to study the question keeps imaginations running at full speed. The rumor explored. So how did this narrative originate? Some media reports claim NASA says warp drive is getting closer to reality. For example, one article states that a spacecraft could sit within a warp bubble, enabling effective speeds greater than light. There are grainy videos and headlines, NASA's new Lightspeed engine that defies physics, on YouTube. This creates a bold claim that NASA has admitted something massive. In truth, NASA is investigating theoretical models, doing lab-scale experiments, exploring ways to reduce energy cost, but no confirmation of a functioning light-speed engine. Therefore, the rumor exaggerates. The kernel of truth. NASA is working on warp drive-type research. The leap, created something so advanced it can reach light speed, remains unverified. We can explore the possibilities, speculate, but must emphasize the uncertainty. The why. What drives this research? Why does NASA dedicate time funding and expertise to something that sounds so far ahead of our current technology? The main reason lies in the sheer scale of space itself. Even with our fastest existing spacecraft, reaching the nearest star systems would take tens of thousands of years. Distances between planets, let alone between stars, are enormous. NASA's own technical document, Warp Field Mechanics 101, illustrates this clearly. At current propulsion speeds, interstellar travel is beyond reach within a human lifetime. The need for faster travel isn't a fantasy, it's a scientific and logistical challenge that demands new ideas. A second reason is inspiration. Many of NASA's greatest achievements began with concepts that first appeared in science fiction, like satellites, moon landings, and reusable rockets. The imagination of writers and visionaries often provides the first spark that later becomes a scientific pursuit. Exploring concepts such as warp drives keeps curiosity alive, inviting younger generations of scientists and engineers to think beyond what seems immediately possible. There's also a practical, strategic motivation. If humanity ever unlocks a form of advanced propulsion, it would transform not only exploration, but global standing in technology and defense. The nation that pioneers faster interstellar travel would gain an edge in every field, from deep space exploration to planetary resource access. NASA's investment in fundamental physics research ensures that the United States remains a leader in understanding and possibly developing these revolutionary systems. Another factor is the feasibility over time. Even if warp drives themselves remain far away, smaller advancements along the path could have major benefits. Research into energy efficiency, exotic matter, and field manipulation might lead to technologies that enhance existing propulsion systems. Every bit of progress brings incremental gains, such as improved spacecraft efficiency, lighter materials, or better ways to store and use power in space. Ultimately, NASA's focus is on pushing boundaries. Their goal isn't to build a warp engine tomorrow, but to deepen humanity's understanding of the universe's laws. By doing so, they lay the foundation for discoveries that could someday make science fiction closer to reality. It's long-term thinking, building knowledge today for a future when interstellar travel might no longer seem impossible. The risks and ethical dimensions. When we speculate about light speed or near-light travel, we must also consider the risks. If such propulsion ever became practical, the consequences could be destabilizing space-time, environmental hazards in space or on Earth, profound disruption to human society, and massive resources diverted to arms-like applications. Ethically, who controls such technology? If one nation or corporation develops a warp-capable craft, what does that mean for others? It raises issues of access, inequality, and militarization. Also, risk of unintended side effects. Traveling at relativistic speeds can expose ships to intense radiation, cosmic debris, time dilation effects, and unknown physical stresses. The theory doesn't yet capture all the practical dangers. And the communication challenge. If you leave Earth on a faster-than-light journey, you might return to a very different world, or never return in the way you expect. The societal and psychological implications alone are massive. How close are we really? Let's ground the hype in context. Several recent articles emphasize that what's being studied is still decades, perhaps centuries away from deployment. The Popular Mechanics piece states warp drives are possible. Aliens may be using them, but we're still far from building one. Another report says the energy requirements have been theoretically reduced, but they remain huge. Even creating a small warp bubble remains in the lab conceptual stage. In short, we're at the what-if stage, not the look at this thing flying to the stars stage. So if you see headlines claiming NASA has built a Lightspeed engine, treat them with caution. The research is promising, imaginative, bold, but highly speculative. The terrifying factor revisited. Why do we call this terrifying? Because when you open the door to faster-than-light travel, you open Pandora's box of possibilities, many of which we cannot yet predict or fully understand. Imagine a scenario. A craft travels so fast it violates our current understanding of how time and space work. What happens to the people aboard? What happens to those left behind? What if something goes wrong mid-warp? The technology might also make warfare more deadly. Missiles that could travel star distance in minutes, or probes that could reach Earth from deep space in unexpected ways. Even from a philosophical standpoint, if humans start traveling between stars, we may face existential questions. What happens when you arrive somewhere and the time you thought had passed differently for others? What does identity mean when you cross epochs? All of this adds to the terrifying quality, not because NASA is announcing doom, but because the implications of real faster-than-light travel are truly profound. What would it mean for humanity? Should such technology ever become real, the transformation would be monumental. First, exploration at the galactic scale. Destinations that now take tens of thousands of years might take years or less. Star systems become reachable. Second, science would leap. We could study exoplanets at close range, perhaps witness life beyond Earth, maybe even colonize. Third, economics would change. Space travel, resources from other worlds, and interstellar trade all might become components of the future economy. Fourth, culture and identity would shift. Humans may become a multi-star species. Our sense of home, our species' story, and our place in the universe would evolve. But also, challenges, governance, resource allocation, safety, identity, ethics, all would require radical new frameworks. Could the human mind cope with speeds, distances, and years that no longer align with Earth's calendar? What to believe and what to doubt? When you watch a headline saying NASA admitted a Lightspeed engine, you should ask, what exactly did they admit? What evidence exists? Reliable science media list theoretical research, but not a functioning craft. Ask, has the technology been demonstrated? Has a photon ship been launched? Has a warp bubble been created? The answer? Not publicly, no. Be cautious of sensational reports that leap from NASA researches warp drive to NASA-built warp drive. They are different. That said, the research is real, the exploration is ongoing, and the possibility remains truly exciting. So you can believe that NASA is working on extraordinary ideas, and doubt that we have Lightspeed engines ready for launch, the most likely path forward. So what's the most likely realistic path? In the short to medium term, next decades, incremental advances in propulsion, higher speeds but still sublight, better understanding of space-time physics, small experiments in warp field detection, e.g. the White-Jude warp field interferometer. Further ahead, if exotic matter or negative energy can be harnessed, we could conceive of practical warp bubbles, but that might still lie centuries ahead, if feasible at all. Meanwhile, commercial and governmental agencies will probably invest in near-term technologies like laser sail probes, high-energy propulsion, and nuclear fusion drives. The leap to true faster-than-light remains the holy grail. The key message: we're not one warp jump away, but we may be one major breakthrough away from transforming what we believe possible in space travel. Why the rumor gains traction? Why do these kinds of stories spread? Because they combine hope, mystery, and fear. The idea that mankind could defy light speed limits speaks to our ambition. The notion that NASA is quietly advancing such technology taps into fascination with hidden knowledge. Headline writers love NASA admits because it implies secret truths unveiled. Social media amplifies it, often without nuance. Meanwhile, the average viewer sees a Lightspeed engine and imagines starships tomorrow. That gap between scientific nuance and public interpretation fuels misinformation. It's not that the science is fake, it's that the translation into NASA built something is misleading. But for the sake of fun speculation and science wonder, it ignites the imagination. How to talk about it responsibly. If you're sharing this topic, keep a few things in mind. Use words like investigating, theoretical, and speculative. Emphasize that while NASA researches warp-type concepts, there is no operational FTL craft confirmed. Encourage curiosity, but not blind belief. Mention the known physics, mass, energy, and causality. Point out the obstacles, negative energy, exotic matter, and immense resources. Acknowledge the rumors, but clarify the difference between studied and built. By doing so, you maintain credibility, respect science, and still enjoy the dramatic possibilities. That balance is especially important in a world where clickbait and sensationalism dominate. The big questions we can't ignore. What happens if humans really break the light speed barrier? What if NASA or another agency succeeds? Will we become explorers of multiple stars? Or will we find ourselves overwhelmed by the scale of the cosmos, or even by threats we cannot foresee? What about time dilation and causality? If you travel at near light speed, or in a warp bubble, the time you experience may differ radically from Earth's time. Could you arrive in a world you no longer recognize? Could the future outpace you? And what if the terrifying part is not the speed, but the ripple effect? Unintended consequences for the universe, for humanity, for time itself. These questions venture into philosophy, ethics, and deep space physics, areas we barely understand. So, as you consider the headline, NASA just admitted they've created something so advanced it can reach light speed, ask, what could it really mean? What should we foresee, prepare for, and hope for? We're standing at a fascinating threshold. On one side, the wild, glorious vision of faster-than-light travel. On the other hand, the sobering reality of current physics and technological limits. NASA's research into warp-type engines is real. The leaps required to make actual light-speed travel possible are enormous. The rumors that they've built it are premature, but that doesn't mean we should dismiss the possibility. Quite the opposite. It invites wonder, debate, caution, and excitement in equal measure. If someday we cross that boundary, it won't just be science. It will be a profound turning point for humanity. And yes, it could be terrifying. So what do you think? Could NASA be hiding something big? Or is this just another step in a long journey toward the impossible made possible? Let us know your thoughts below.